Hey, QR. You can see that I don't have any technology with me, and so I'm just going to go over my completed notes. So, the first thing that I wanted to restate is that we have empirical probabilities and we have theoretical probabilities. So, the empirical probability is based on an actual experiment, and the theoretical is based on what should happen. And so, when you flip a coin, you would expect that it lands on heads half the time. But when you run an actual experiment, you may find that that does not actually happen. So in this first example, we toss a coin and it lands heads up 35 times out of 100. So this is empirical probability because it's an experiment that we actually did. And so to find the probability that it landed heads up, we take the number of times it landed on its head divided by the actual tosses. So it landed heads up 35 out of 100 times. And then we always want to fully reduce all of our fractions. That's how you should see it on all of the tests. Another example of empirical probability is a drug test. And so we had 400 individuals that we tested. And if we wanted to determine the probability that a person blood pressure was reduced by this, then we would write that as 267 out of 400. If we wanted to find the probability that it was unchanged, we would look here. And so it was unchanged 74 out of 400 times. And then I didn't do what I told you, and I'm sure that I should have definitely reduced that one. And then what was the probability that the medication increased their blood pressure? And so it increased it in 59 out of the 400 people. So from now on, when we talk about probability, we are going to refer to theoretical probability. What do you expect should happen? And so for that, this is the probability of an event is the number of outcomes favorable divided by the total number of possible outcomes. So we're going to roll a die, and we want to determine the probability of rolling a 2. So we know that there is 1 2 out of 6 sides of a die, and so the probability of rolling a 2 is 1/6. What is the probability that you roll an even number? So an even number is a 2, a 4, or a 6. So there are 3 even numbers out of 6 on the die. So you would reduce that to 1/2. What is the probability that you get a number greater than 2? So it doesn't say or equal to, so that means it is only the numbers 3, 4, 5, and 6. There are 4 favorable outcomes that are greater than a 2 out of the 6 possibles, and so that would reduce to 2/3. What is the probability that you get an 8? Well, there are no 8s, and so that would be 0 out of 6, which reduces to 0, and a probability of 0 means that it will never occur. What is the probability that you get a number less than 8? Well, all of the numbers on a die are less than 8, so that will occur 6 times out of 6. That reduces to 1, and if you get a probability of 1, that means that it will always occur. It is certain to occur. So here are some probability facts. If you get a probability of 0, that means the event cannot occur. A probability of 1 means the event must or will occur. Every probability is a number between 0 and 1 inclusive, meaning it could include a 0 and it could include a 1. The sum of the probability of all possible events is 1. So think of rolling a die. So the probability of getting a heads is 1/2. The probability of getting a tails is also 1/2. And 1/2 plus 1/2 equals 1. So now we have a chart, and we have the names of 9 different birds here and what kind of kernels they like. We listed the birds' names on a slip of paper and put it in the bag, and one slip is going to be selected at random from the bag. Determine the probability that the slip contains the name of a finch. All right, so when we look here, we have goldfinches. No. And we have a house finch. And so there are 2 out of 9 finches. So that probability is 2 ninths. All right, so all these LH and mediums is their attractiveness to it. So for peanut kernels, an American goldfinch is low attracted. Cracked corn, low attractiveness to it. But a black striped sunflower seed, it is highly attractive too. So that's what all these L's and H's are. So the probability that a blue jay, so they don't like they do like peanut kernels. They have a medium attractiveness to cracked corn and a high attractiveness to sunflower seeds. So what is the probability that a bird has a high attractiveness to cracked corn? So in the cracked corn column, when I look through here, I only see 1 H out of the entire column out of 9 birds. And so there is a 1/9 probability that you draw the common grackle bird. What is the probability that a bird has a low attractiveness to peanut kernels, a low attractiveness to cracked corn, and a high attractiveness to black striped sunflower seeds? All right, so it gave me an LLH. So I went back up here and I looked for that combination, LLH. So there's one there with the goldfinch. This grosbeak has an LLH combination. And this northern cardinal has an LLH. And so I found 3 of them out of the 9 birds. And when I reduced that, there was a 1 in 3 probability that I will have a bird that meets this criteria to the food. What's the probability a bird has a medium attractiveness to either peanut kernels or cracked corn or both? Okay. Peanut kernels, cracked corn. So we're looking for a medium. So there's one on the blue jay. There's a chickadee. There's the grackle. There's the house finch, the sparrow, and the mourning dove. So I found 6 birds that have a medium attractiveness to one of those kinds of food. And so the probability that I find a bird with that criteria is 6 out of 9, and that reduces down to 2/3. All right, so the sum of probabilities equals 1. So the probability of event A plus the probability of event B equals 1. So like the coins that we were talking about earlier, the probability of rolling heads plus the probability of rolling tails, you have 1/2 plus 1/2 equals 1. So sometimes you want to find the probability that something does not happen. So the probability that you do not get the heads would be 1 minus the probability that you do get a heads. And so the not is 1 minus the probability that it does happen. So that is a formula that you could use. The next section, we're going to do some card problems. So we have a standard deck of 52 cards. Really wish this would have had an image that was in color instead of black and white. So we have 4 suits, the hearts, the clubs, the diamonds, and the spades. These are called suits. Two of them are red, the heart and the diamond. Two of them are black, the club and the spades. There are 13 cards per suit. So if you count ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, there are 13 there. So 13 times 4 gives you 52. It might ask you about face cards. The face cards are the picture cards, the jack, the queen, the king. So you can see that there are 3 of each suit, and 3 times 4 is 12. So therefore you have 12 face cards. This says one card is to be selected at random from the deck. Determine the probability that you select an 8. So when you look up here, you have 4 of them because there's 1 in each suit. So there are 4 cards out of 52. And if you reduce that, the probability that you get an 8 is 1 in 13. What's the probability that you do not get an 8? Well, I went back and I used this formula here. The probability that something does not happen is 1 minus the probability that it does. So instead of counting up all the other cards, I used this property and I said 1 minus 1/13 equals 12/13 probability that you do not get an 8. What's the probability that you get a spade? Well, you could either reason through it and say, well, there are 4 different suits, and so a fourth of the cards are any of these suits. Or you could say, okay, so there are 13 spades out of 52, and that still reduces down to 1 in 4. What's the probability that you get a face card? Up above, we said that there were 12 of them out of 52, and I reduced that. So the probability that I draw a face card is 3 in 13. What is the probability that I get a diamond and a club? So this word "and" means that it has to be both a diamond and a club, but something cannot be 2 suits at once. And so this probability is 0. It cannot be multiple suits. What's the probability that a card greater than 4 and less than 10? All right, so I wrote them down and I determined that you could draw a 5, 6, 7, 8, or 9. So there are 5 cards right here, and there are 4 suits. So there are 20 different cards that are between 4 and 10. So 20 out of 52 possibles, and I reduced that, and I got 5 out of 13. So you can take as many notes as you like. Hopefully this gives you the skills to be able to do the homework. And let me know what questions you have when we get back to class on Wednesday. See ya.